Dear students, Namaste everyone. Welcome back to this session. In the last session, we were solving a problem on boson distribution. That is especially problem on boson fitting. Now here, that problem is like this. There is a fitted boson distribution for the following data, and the data will be given with regard to number of printing mistakes, right? And we defined that the number of printing mistakes. Then number of pages will be given. This represents the given distribution is an observed frequency distribution. And then after that, we have, since in this problem lambda is not given, we have calculated the parameter lambda by equating the theoretical mean with the observed mean, and we got in that problem x bar, the observed mean, is equal to 1. Next up, we have equated the theoretical mean with the observed mean. Lambda is the theoretical mean and the x1 is the observed mean, and that is lambda equal to x bar equal to 1. Therefore, we wrote x follows boson in bracket lambda equal to 1. After that, we must write the probability mass function. Then with the help of the probability frequency function, we can write Tx is equal to n into p of x. We wrote in the last class Tx is equal to n into p of x. After that, we calculated T0 by substituting x is equal to 0 in the frequency function, and the answer we got it as 36.79. And the remaining frequencies are calculated with the help of the recurrence relation. Tx is equal to lambda by x into Tx minus 1. That is Tx equal to lambda by x into Tx minus 1. After that, in the recurrence relation, I substituted Tx equal to 1, 2 and 3 in the last class. Till T3 we calculated. Now let us start from T4. How to start finding the value of T4? That is, put x is equal to 4 in the recurrence relation lambda by x into Tx minus 1. Now T4 is equal to lambda by x. In this problem, lambda equal to 1. So 1 divided by x. Here x we wrote it as 4. So 1 by 4 into Tx minus 1. That is a T4 minus 1. That is a T3. Which is equal to 1 by 4 into T3. That is we got in the earlier class T3 equal to 6.1317. Now here simplify this. 6.1317 divided by 4. You will be getting the answer 1.5329. 1.5329. Next, put x is equal to 5. That is T5. Here x is equal to 4. This is put x is equal to 5. T5 is equal to lambda 1 divided by x. X is 5 into Tx minus 1. T5 minus 1. That is a T4. Which is equal to 1 by 5 into T4. That is this answer 1.5329. Now simplify. 1.5329 divided by 5, which is equal to 0.3065. This is the answer. Now we calculated all the theoretical frequencies. Once we got it, next first we must approximate it to the nearest integer. Now T0 36.79. Look at this first decimal value. It is 7. Which is greater than 5, so it becomes 37. Increase the integer part by 1 unit. Similarly here 18.39, since it is 3, don't increase 18, we must write as it is. Next T1 equal to 36.79, 36.7, so it becomes 37. Similarly 6.13, this one is less than 5, so retain the integer as it is, 6 itself, right? Next 1.53 approximately equal to 1 point. It is the first decimal value is 5, so which is equal to 5. So increase the integer part by 1 unit. 1 plus 1, 2. Right? I think we are following the approximation procedure. 0.30, it becomes 0. So now I have approximated all the values. Then just find the sum. the sum must be always equal to capital letter N. Here capital letter N is a 100. Capital letter N is a 100. So just check whether the sum of the theoretical frequencies is 100. So 37 plus 37, that is 74 plus 6, 80, 98 plus 200 plus 0, 100. So we will be getting the sum equal to 100. So we need not approximate, we need not to adjust any frequencies. So directly we can write next up, therefore the theoretical frequency, therefore the theoretical frequency distribution is given by first row number of printing mistakes, or we have to write it as a X. Second row number of pages F, and third row theoretical frequency is Tx, right? Here n is equal to 100. Next theoretical frequencies obtained values. First one 37, next one T1 37, next one T2 18, T3 6, T4 2 and T5 0. This sum must be equal to, we will be getting. Right? This is how to fit a Poisson distribution to the given data. Now let us see the one more problem, second problem on Poisson fitting, and the problem is fit a Poisson distribution for the following data, and it is not given. Write down the theoretical frequencies. It is understandable. We have to write the theoretical frequencies. Now here the data is be given like this: number of TV sets sold, next number of days. Then number of TV sets sold 0, 1, 2, 3, 4, 5, and the last value is, it is not 6, 6 and more. In the earlier problem, a specific value is given and we can observe it is 5. So here in the earlier problem, specific value is given at the end, and here the last value of x is not a specific value, it is something and more. In this case, there is a small change in solving a problem at the last part. Okay. So here, next number of days it is given, and here what is x? The first row heading always represent x. X denotes the number of TV sets sold, and since we are dealing with now Poisson distribution, it must be per day, per week or something. Here then look at the second row, number of days. So I can write, let x denote the number of TV sets sold per day. This is how to define x. Next after that, first find lambda. Whether the lambda value is given here? No, nothing is given here with regard to the parameter value. So since parameter lambda is not given, we have to find this by finding the observed mean and equating it with the theoretical mean. Is it right? Okay. Now here first find x bar. Here since here we can write lambda is not given. Lambda is not given. Therefore, we have to find the x bar. To find the x bar, we need to find the sigma fx values. Sigma fx. Before that, we have to define, let x denote the number of TV sets sold. The number of TV sets sold per day. Right? Per day. Next then x follows Poisson in bracket lambda equal to something. That lambda we have to calculate it. For that, first find sigma fx. Now this is x and it is f. Now multiply both. For example, 0 into 18, 0, 1 into 43, 43, 2 into 45, 93 into 28, 4 into 12, like that. Multiply and write the values of fx. Those values are fx values. First one 18 into 0, 0. Next 1 into 43, 43. Next value is 45 into 2, 90. Next one 2 into 28, that is 84. Next 12 into 4, 48. Next one is a 20 into 4 into 5, 20. Next last one 6 and more into 0 means in such cases just multiply 0, or if there is a number multiply that f value into the significant value given in that factor, that is 6. 6 into 0, 0. Right? Now add all the values. You will be getting sigma fx is equal to 285. Sigma fx here you will be getting 285. After that, first find the x bar. X bar is equal to sigma fx divided by capital letter N, that is a 285 divided by capital letter N is a 150. What is capital letter N? That is a sum of the values of f. That is here it is N which is equal to 150. Next 285 divided by 150. The answer is 1.9. 1.9. Next equate this observed mean with the theoretical mean x with the theoretical mean lambda. That is we can write. Next is consider lambda equal to x bar equal to 1.9. Next therefore x follows goes on in bracket lambda equal to 1.9. So mention the distribution with the value of the parameter. After that, write the probability mass function. The probability mass function is p of x equal to e power minus lambda power x divided by x factorial. X is equal to 0, 1, 2 up to infinity, which is equal to e power minus 1.9 power x divided by x factorial. X is equal to 0, 1, 2 up to infinity. This is the probability mass function. Next, write the frequency function. Frequency function is Tx is equal to n into p of x, right? That is Tx is equal to n, capital letter N is 150 into p of x is this probability mass function e power minus 1.9 power x divided by x factorial. X is equal to 0, 1, 2 up to infinity. Now the same procedure we studied in the binomial distribution also. Now next put x is equal to 0. Put x is equal to 0 in the frequency function. You will be getting T0 is equal to 150 into e power minus 1.9. That is from the table you must get that value, and that is a 1.9. Like this you must see, here you will be getting the answer. That value is 0.1496. 0.1496 into 1.9 power x, that is a 1.9 power 0 divided by x factorial, 0 factorial. So this factor becomes 1. Similarly 0 factorial is also 1. So you will be getting 150 into 0.1496. Multiply this and the answer is 22.44. 22.44 is the answer. Next, once you got T0, remaining frequencies are calculated with the help of the recurrence relation. So the recurrence relation is Tx is equal to lambda by x into Tx minus 1. Put up 1 by 1 starting from x is equal to 1. So put the different values of x starting from 1. So T1 is equal to lambda. Lambda is 1.9 divided by x. X equal to 1 into Tx minus 1. T1 minus 1, that is a T0. Right? This which is equal to 1.9 divided by 1, that is 1.9 into the value of T0. T0 is just obtain the value 22.44, which is equal to 42.636. 42.636. Next value. Next, put x is equal to 2. Put x is equal to 2. That is T2 is equal to lambda. Now always look at this recurrence relation. Put x is equal to 2. T2 equal to lambda. That is 1.9 divided by x. Just now we substituted it as 2 into T2 minus 1 T1, which is equal to 1.9 divided by 2 into T1, that is 42.636. The answer is 40.5042. This is the answer. Next, similarly, put x is equal to 3. Put x is equal to 3. T3 is equal to lambda 1.9 divided by x3 into T2, which is equal to 1.9 divided by 3 into T2. Just obtain the value, that is 40.50, right? 40.5042, right? Is it clear? Now once again 1.9 into this divided by 3, you will be getting the answer 25.6527. 6527, right? Next is now put x is equal to 4. T4 is equal to 1.9 divided by x. X is 4 into T4 minus 1, that is T3. 1.9 divided by 4 into T3. Just obtain the value 25.6527. Multiply these two divided by 4. The answer is 12.1850. 1850. Next, put x is equal to 5. T5 is equal to lambda by x. X is 5 into T4, which is equal to 1.9 divided by 5 into T4, 12.1850, which is equal to 4.6303. So 1.9 into 12.1850 divided by 5. Right? Write everyone 4 decimals. Only while writing the value of lambda, approximate it to 2 decimals. Right? Next one. Here the last one, to find the last value. That is T6 and more. Here we cannot substitute x is equal to 6 because the last values of x is not only 6. It may be 6, 7, 8, 9, 10, whatever it may be. Either 6 or more than 6. So it is not possible to substitute here x is equal to 6. Here what we are going to do is to find the theoretical frequency with respect to such factors. First, add all the earlier calculated theoretical frequencies. That is, the previous theoretical frequencies should be added and subtract the sum from capital letter N. Right? That is, we can write here T6 and more. Right? Like this we can write T6 and more is equal to, that is a Tx value or more. Right? Which is equal to capital letter N minus then all the sum of all the previous values of Tx. That is starting from T0. T0 plus T1 plus T2 plus T3 plus T4 plus T5. Right? So 6 and more. So till T5 we must add. By adding first capital letter N, that is a 150. Capital letter N is a 150 minus here T0. T0 means consider the value in decimal form only. That is the T naught, we got it as 22.44 plus T1, next value 42.636 plus next value T2 40.5042 next plus so T0 to T1 T2 next to T3 25.6527 plus 12.1850 plus 4.6303. So T0, T1, T2, T3, T4, T5. Add all the values and write the sum. 150 minus, that the sum is 148.0482. Subtract it from here, which is equal to 1.9518. Right? 1518. Now this is how to find the theoretical frequency corresponding to the lapsed value of x, if x is in the for a particular number and more or more than some number, right? Only the difference in solving the earlier problem and this problem is in the last step, right? In finding the last theoretical frequency. Here n minus the sum of the earlier theoretical frequencies we have to use. Next, once you want all the theoretical frequencies approximated to the nearest integer. So first one T naught 22.44, it becomes 22, right? And next one 42.63. So here I can write it as 43. So since it is 6 greater than 5, so increase integer by 1 unit. 40.5, so increase this integer also by 1 unit because it is 5. And next one 25.65, so it is 26. 12.1, 12. Next one 4.6, increase by 1 unit, 5. And just last one 1.95, it becomes 2, right? Next, now find the sum of those frequencies. We got the frequencies as first one 22, right? Just I will write here 22, and the second one we got it as 43, third one 41, next 26, next one is 12, after that 5, and last one is 2. Now these are actually just to obtain the theoretical frequencies. Add it and see the sum. Here actually the sum must be equal to 150, but you will be getting the sum as 151. Here you will be getting the sum as 151. We must adjust it to 150. So one value we have to decrease by 1 unit. So just mark the values of Tx which are already increased by 1 unit. Already increased, not by 1 unit, increased. Just mark. First one 42.63, mark it. 40.50, we increased it. Similarly 25.65, next 4.63 and 1.95. So marked values that we can observe, we have increased the integer part of those numbers by 1 unit. Among those marked values, reduce one value by 1 unit. Which one? Which is very near to 0.5. Now here look at the 2 decimals. First 2 decimals, it becomes 63, 63. You can read just and 50. So 63, 50, 65, 63, 95. Among those 5 values, which is the nearest to 2.5, that is 0.50. So instead of writing this 41, we can write it as a 40. Decrease it by 1 unit because it is very near to half. So here instead of 41, I can write it as a 40. Now you can observe this sum becomes sum of the theoretical becomes frequencies which is equal to here. Therefore, at the end you can write therefore the theoretical frequency distribution is number of TV sets sold x, next write f, and the third row you can write fx. Tx. At the end always we must write the theoretical frequency distribution obtained. So therefore the theoretical distribution is Therefore, theoretical frequency distribution is, write this x, f last row is tx, that is 22, 43, 40, 26, 12, 5 and 2. Now this sum becomes 150. Yes, this is how to fit Poisson distribution. Those are simple, but just always before starting the problem on Poisson fitting, just to see how the data will be given, whether the last value of x is directly given or in the form of some number and mode. According to that, we must decide how to do the problem. Next, one more problem I wrote here. Similar problems already we solved. Just if 98% of electric bulbs manufactured by a company are known to be non-defective, what is the probability that a sample of 150 electric bulbs taken from the production process of that company, so here it is asked to find the probability, would contain exactly one defective bulb, another one more than 2 defective bulbs. More than 2 defective bulbs. Now first look at this problem. We have to study about defective bulbs. So probability of some number of defective bulbs. So x may be number of defective bulbs. Is it right? And we have seen the distribution of number of defective bulbs is always binomial distribution. And how the problem will be given? Whether it is a problem on binomial or converted problem, that is in the form of Poisson. It is given 98% of electric bulbs manufactured by a company are not defective. So probability of a bulb is not defective is 98%. Probability of a bulb is not defective is 98%. So here we have to find, just I am going to give hint to solve this problem. Solve yourself, but just I am going to give hint. So what is x? Let the x denote the number of defective bulbs, right? Defective bulbs. Among how many bulbs? It is given a sample of 150 electric bulbs. Remember, a sample has 150 electric bulbs. So among 150 electric bulbs, that is actually x follows binomial in bracket n is equal to 150, p is equal to probability of an item is defective. Is it 98%? No, 98% are not defective. Right? That is 2% are defective. Is it clear? So convert here, probability of failure is given. Convert it as probability of success. So probability of an item is defective is 2%. Q equal to 98%, right? That is 0.02. This is 0.98. This is how to understand the problem. So here n is equal to 150, p equal to 0.02. Now you can observe here, since n is large, it is 150, very large, and p is small, it is 0.02. Convert the given problem as a Poisson problem, right? So Poisson distribution can be used. Therefore, consider lambda equal to np, which is equal to n is 150 into p is 0.02, which is equal to 3. Therefore, x follows Poisson in bracket lambda equal to 3. Next, continue with the Poisson distribution. I think you can continue that. Exactly one defective means probability of x is equal to 1. Put x is equal to 1 in the probability mass function. Similarly, more than 2 defective means p of x is greater than 2. Right? So which are the values required? 0, 1, 2, 3, 4 up to infinity. Greater than 2. From 3 we want the values. Right? Greater than 2. 2 is not included. So 1 minus p of x equal to 0 plus p of x equal to 1 plus p of x equal to 2. You can do it. Do this problem. Thank you, students.